So now rolling resistance. So do you think the air pressure actually matters for IC engine vehicles or EVs?
Yeah.
So does it matter more for an EV or an IC engine vehicle? Okay. So the thing is, the IC engine vehicles are slightly more powered and then RPM. You have gear ratios in them. So and we have fuel petrol pumps. So the main thing is we don't keep that in mind, and it has become a secondary behavior that like how many of you when you go to a petrol pump you check your air, like, fill air there, you don't do that, right? But in EVs, if you don't do that, you'll be losing out on your range because the motors are very sensitive. And so just a simple example is that they use 250, the Ola motor which it's there in the Ola vehicle, right? The mid-drive one, not the hub motor one. That motor is used for three-wheelers also, which can carry a payload nearly of around 800 kgs. So when you are using such a small, like a limited power motor for such an application, if the air pressure is not good enough, it is going to affect your range because the rolling resistance is going to increase. Simple reason, like we have these tires, like there are two kinds of tires. Have you clearly seen a distinction between a cargo vehicle and a passenger vehicle? So do you know what are they called? Two different tires.
Bias, that is tube and tube.
No, it is called a radial tire or a cross-play tire. You don't see a Bolero pickup tire sagging at the bottom. It is neatly round. But in a car, it's radial. And I think all of you guys will have a clear. You have seen all the sports cars, right? They have very low profile. Meaning, you take a tire, they have very thin area of the tire. Why is that there? Why do they have a smaller sidewall?
More contact.
That is your tire width. So this is just a small addition to it. When a tire you're hitting, like you're going in a bike at a speed of around 50 km per hour, like a normal Pulsar 150cc vehicle, and you hit a speed bump. When you hit the speed bump, the vehicle weight is 100 kgs, 120 kgs, you are around 80 kgs heavy, 200 kgs, and when you hit the speed at 50 km per hour, pretty much the load that is going to come at that point on the tire when you're hitting that road bump is going to be nearly close to 800 kgs or close to a ton at that moment. So what that does is the tire is the first suspension acting member in the whole vehicle. So you need to choose your tires right, and when you start designing, it's from the tire size which you go. So that is the reason you see all sports bikes or the cruisers and scramblers have very low profile tires. Because when you're hitting 150, 160 on the highway, if you have a high profile tire, your vehicle will bounce. So if your vehicle, like it's a small ditch, maybe half-inch ditch is there on the highway. It's like a dip. So what would have happened? Some random minister would have dug it open and the plant would have sunk in there. And you will be going at 100 or 120, and when the vehicle goes in the ditch, no, the vehicle bounces back like this. If it's a low profile tire, it will not throw you. It will control. If it's a soft suspension and a high profile tire, sorry, a low profile one will throw you out. That's why on racetracks you don't see bumps. If you do that in a case like an RC390, there are chances that it will throw you out of the vehicle. You need to hold it tight. But an RE Himalayan will just glide through it because it has soft suspension and high profile tires. That is the clear distinction, and that needs to be clearly said. Now, if you have high profile tires when it comes to a moped, it is utilitarian. You can't give high profile or low profile. It needs to be in the middle. It needs to give you a good ride and carry load. So they have higher profile so that there is more load, the wheel will be able to take it. So in super bikes, it is a trade. There is no trade-off. It's straight up low profile. And have you noticed a distinction between the front wheel of the tire of a bike and the rear wheel of a bike? It is wider and
size will also.
Yeah. So the front wheels will always have a higher sidewall depending on it, and the rear wheel will have a lower sidewall. So why is it like that? Why does the front wheel have a higher sidewall? Huh? Does no? So partly right, but the main thing is that when you're going on the road, right, when the bump hits, the front wheel that's going to hit, and the load transfers from the front. So wheels with higher sidewall in the front, they are more stable. But in case of dirt bikes, they have huge wheels and a decent sidewall so that it can climb over stuff easily, and the rear wheel will just follow after that. So that is the main thing. So that is why these XLs run a same 19-inch, 19-inch wheels. Inventory is same. You don't have to maintain another rim. Same tire size, so front and back is the same. But for a Pulsar or anything, front is a 100. It is a 19-inch, 100 width tire. The rear is a 17-inch, 130 mm. So that is in the rear it changes again because that is done to give you a better trade-off on the ride quality and stuff. So to just calculate this, the first is we have mass into m into g, normal, right? And then we have the coefficient, rolling resistance coefficient. That is standard chart. So based on that, which we are going to be using normal bike tires. So bicycle tires, you can consider that. I've considered that for 400 kgs and I've got 9.8 Newton. This resistance is only when you are moving the vehicle. Like once the vehicle started, the resistance will slightly go down. And one more thing is this resistance will change on like traction, like on off-road areas, and depending on where the vehicle is going. So when you see more road use vehicles, they have lesser treads. That is because we need more contact area in order to move quickly, and it's not going to go off-road. For off-road going vehicles, what they do is they give a lot of gaps between the buttons, so that the dirt or water, when you just go through it, that dirt and water moves into those grooves, and that tire patch will contact the ground. So I always had this fascination of using a dirt tire on the bike, but the problem with that is the dirt tire will start going quickly. You'll wear the tire out in 10 kilometers because the tire is completely in contact with the ground and there's high friction on the tarmac. But in off-road areas, right, the wheel tends to skid a lot. They will move in that way. So that digs in and it has to go. So just to give you an idea of the off-road things, like off-road vehicles, there will be 2.5 inches of gravel, like 2.5 to 3 inches of loose sand. So when they accelerate, this wheel, each button will be close to another 1.5 inches. So when you throttle the vehicle, right, the vehicle skids, the vehicle rotates, wheel rotates, and you dig in, it touches the ground below and move. So that is the whole perspective of it. But that doesn't happen in terms of a off-road vehicle. So that is one thing. And then we have gradient. So gradient is again when the vehicle, like this is again basic calculations. When the vehicle is on a gradient, this is the gradient angle on which it's going to go. But we will not be able to see it like this on any roads. So in Bosch and all these companies for a test track, they have a ramp. They vary the central height and they check the stalling. So whenever it's LD, they check the stall torque. Meaning when the vehicle goes and stands on this incline, it has to hold itself. Like they'll stop the vehicle midway and then they'll accelerate. That is called as peak torque. Meaning in a motor we have two torque or two power ratings. One is nominal and one is peak. So peak is that, suppose if you guys are like if you're trying to pull water out of a well, so the first pull when you hold the rope and pull the first time, you'll put a lot of effort for that. And after that you go continuously pulling it, and that time you will not have to put that much of effort. So the first thing which you pull, that is how the motor moves the vehicle. That is the peak torque. So in Ola and all, there is 8 kilowatt peak. So that jolt of power which comes in is for a very short duration of time. After that it comes down to the nominal level. So that is how these motors work. But in IC engines, we have a different power curve, and in that we have different gear ratios, and so that it works. So here again, this sign component of this force which is pulling the vehicle down. Now the sign component of it is the one which is going to prevent the vehicle from going ahead. So mg sin theta is going to be a gradient resistance. Okay, this changes with different gradient. So we need to consider, whenever we consider the overall force needed to move the vehicle or select the battery, so keep everything at fixed. So the first thing is gradient, my max gradient for all the vehicles should be considered up to 15 degree. 15 max until 20. So after that, and the max speed you go to. So for that comes the aerodynamic drag force. So each vehicle, we are not seeing this Vande Bharat train, right? Why that capsule shape is to make it aerodynamic. So those trains maybe they're going up to 140 to 150 km/h speed. So for such a huge size of a vehicle, the shape is very important. So the shape is very important, and so what they do is that projected area. So in companies, they actually have this light room where they keep the vehicle and they project the light and see the profile. And even mechanically, like when you build a component also, something called as profile projectors. You'll have a small bearing, but you'll not be able to see the contours. They'll keep it in front of a light and they'll expand it back so that you can study the profile. So similarly, each line or every single like a bend on the car from the front area matters. So here, for calculating the